My name is Sanskar. In the morning, I work as a software engineer at Bloomberg, where I help create tools for bond trade evaluation. And during the night, I maintain an open source software called Robin. Speaking of Robin, what is Robin? Simply put, Robin is a fast async Python web framework with a Rust runtime. Let's have a look at the current state of Robin. So Robin is currently hosted on GitHub. It has a BSD 2.0 clause. It has around 1,400 stars on GitHub, around 300,000 installs on PyPI. But most importantly, it's under active development. Now, by this time, I'm pretty sure many of you must have had this question: why another web framework? What helps Robin actually stand out? So here are some of the key features. Firstly, it's under active development. Second most important feature, that it's not written in just another language. It's written in Rust, by the way. It has a multi-threaded runtime. It has a very simple API, and it's fairly extensible for you. It's fast, and it can serve around 10,000 requests in 0.692 seconds on a dual-core MacBook, which is a very old machine. If you want the latest stats, you can check out the latest release on a very strong machine. It supports async. It has multi-threaded file and directory serving, dynamic URL routing. It supports middleware WebSockets. It supports something called constant requests. I'll be explaining you what that is. But most importantly, it's community first and truly open source. It follows this ideology to an extent that if you have followed me somewhere or if you have met me in the conference, you must know that I'm not a big fan of type support. But community loves it, apparently, so community shall get what they ask for. So it is a fully type supported system, and you can use the type safety like you all love. Now comes the juicy part. What is the Robin story? Why did I invest so much time in making another framework? It was April of 2021, and it was the final year of my university, and my thesis deadline was approaching. And like any other hardworking student, I was spending all my time exploring Reddit. Sometime around then, a big company decided to introduce Rust into the kernels, and Reddit was filled with this meme: rewriting everything in Rust. And since I was such a dedicated student, I was working on a completely unrelated project called Encrypttext that had a Flask backend. And during that time, I used to write a lot of Node.js and React. And the thing that bothered me about Flask was the lack of async support. So I thought to myself, you know what would be cool, Sanskar, if you could create an async supported Flask? And you know what would be cooler? If it would be written in Rust, by the way. Because during that time, I came to know that Ryan Dahl, who was the creator of Node.js, created another framework called Deno, which used Rust. So maybe this language is not a bad choice after all. But the most important questions of the slide: why the name Robin? Because if I take care of something called Robin, I help it grow, and I help it develop, that automatically makes me Batman. So if I'm a little slow in reviewing the PRs, or if I'm not responding on the community, just have a bat signal beside you, and I have a moral obligation to respond to your question. Now coming to the technical part of the talk. Let's have a look at the traditional Python web app lifecycle. So usually we have a reverse proxy in the frontmost part, a web server. A reverse proxy is something like Nginx, Caddy. A web server is an ASCII or a WSGI. And finally, we have our web framework sitting at the end called Flask, Django, FastAPI, and so on. So let's have a look at a traditional Flask app. I like Flask a lot, and I'm really inspired by the API. And so this is how a Flask app looks. So how many of you folks know how to create a very basic Flask app? All right, perfect. So you import the Flask class from the app. You initialize the app, and you add some decorators to add the routes. So this is how Robin's API look. You import Robin from the Robin module, you initialize it, and you create routes for it. I have made some changes in the API that I felt would make it more useful and more friendlier, according to my experience. For example, you don't have an app.route method, you have an app.get, app.post, and so on methods to define the routes for your application. And also, another reason for me to create an API that was so similar to Flask was to reduce the learning curve to explore a new framework. Because most of us are already familiar with these frameworks, and writing a very different framework would be a very big commitment for everyone. So this is how it looks like. Now let's have a look at the server aspect of the code. A question to the audience: how many of us know what a WSGI or an ASGI is? Okay, so this is a code snippet of a very basic WSGI. A WSGI stands for Web Server Gateway Interface. The reason why WSGI were created, I think 20 years back, was because there were so many web frameworks at the time, but there was no standard to actually serve them. And it was getting very hard for the framework maintainers to serve the application. So it was released in Web 3.3.3, if you folks want to check it out. This allowed the framework maintainers to focus on the routing side and the execution side, where the WSGI would take care of all the dirty parts like handling HTTP requests, handling the response for you, so on. WSGI and ASGI have a lot of benefits, but for Robin, you do not require an ASGI server. Robin comes with a coupled ASGI server, so it is one of the reasons that makes it much faster than everyone else. So this is how a lifecycle of a Robin app would look. It is as simple as writing Python 3 app.py. You do not have to decide between choosing the right WSGI or an ASGI server, so no gunicorn, no uvicorn, no starlet. You just write Python 3 app.py, you put it behind a reverse proxy, and you have your working server. Now let us have a look at the architecture to have a sense of what actually is happening. First of all, we have a worker event cycle that basically does all the heavy lifting for you. This part manages the runtime. It passes all the instruction to the Rust code, and then spawns a thread pool in the middle. So when we type the command python app.py, the Python code is converted to Rust objects, as you can see here. And then it is populated in a thread-safe router. And when the incoming requests come to the router gets the Rust object from the mapping, passes it in a thread pool, depending on if it's a sync function or an async function, and then the response is executed and then returned back as a response. But to scale it to even more extent, we have a TCP socket that's listening to the request, and we can have multiple processes as well as multiple workers now. So all the thing that I explained earlier can be scaled across multiple cores of your machine. So this is also another reason why Robin is faster compared to other frameworks in the market. Now, this feature called const request optimization, for the lack of a better name, was released a week back. So I realized that the encircled part is very GIL dependent. How many of you know what a GIL is? Okay. So GIL is basically a global interpreter lock, which in Python accounts to the slow performance. For some reason for the slower performance, because it doesn't allow like a true multi-threaded experience. So for simple things like serving, let's say, hello world, or serving a JSON schema, acquiring and releasing GIL would be a big overhead. So we realized, wouldn't it be cool if it would just be eliminated, and the Rust, we were able to serve Rust, like the response directly from the Rust side without ever invoking the Python object. So these are different ways I could think of on writing hello world in Python and serving. So we have f-strings, dynamic f-strings, strings that are converted on the fly. So I went on and disassembled this code. And this is how Python looks in assembly. On a closer inspection, you see that only a constant is loaded before a return value is returned. So all of this is replicated in all the patterns below. So how automatic const request optimization works is that it sees the assembly, it pre-computes the value, stores it in the thread-safe router, and without ever like acquiring or releasing a lock, it serves the response back to you. So automatic constant request optimization is still under work, whereas the constant request optimization is already present in version 17.0. So this was just too cool for me to not just show off and make you folks feel excited for 17.1. Now coming to the usage, you can simply do a pip install Robin or install it via Conda. You do not need to have Rust installed on your machine. Now we have a little feature showcase to get you folks excited. So Robin supports synchronous functions because many libraries still have synchronous functions, and as much as I wanted to make it fully async, we need synchronous support because some library maintainers either can't upgrade the libraries or don't want to. It's a very hot topic, and we don't want to start a debate here. It obviously supports async function because it was one of the core reasons behind Robin's origin. And I was a React developer as well, and it always bothered me that I was unable to serve React applications from a Flask app very easily. So I created a way to add sub-routes, and you can serve multiple React applications on a single server using the add directory method. We have static file serving, which is much faster than the native Python file serving. So if you ever want to serve like large files on a machine, on your web server, it will be much faster than using the native Python way. We have dynamic URL routing, so if you want to have route parameters in your route, you can use it like that. So it also scales across multiple cores. So you can scale it as multiple workers as well as multiple processes if you have any restriction on the number of threads that you can use on your server. We have middlewares for logging, for authentication, and we all love middlewares, basically, yes. We support WebSockets. So your real-time applications are also supported in Robin. Constant requests, and much more at the GitHub repo. Now, if you folks are still not excited, we have the performance comparison. But a PSA that this comparison is not to demean any framework or the people associated with the framework. These frameworks are the reason why I got involved in the Python ecosystem. But here you go. So this is a comparison between Flask, FastAPI, Django, Robin on 1 worker, and Robin on 5 workers. So as you can see, Flask took around 5 seconds to serve 10,000 requests. FastAPI took 4 seconds. Django took 13. Django with GUnicorn took 13. Robin on a single worker took 1.8 seconds, whereas on with 5 workers, that was the maximum workers that could be allocated on my dual core machine, it took only 0.69 seconds to serve 10,000 requests. Now, seeing what's in plan for Robin for the future, I want to make it more performant, add OpenAPI integration because it is a better way to write documentation. I add Pydantic support, implement automatic const request optimization, ORM supports, improve the plugin ecosystem, better documentation, improve the WebSockets. And I came to realize in this conference that people want to add template support like Jinja templates. So to support Jinja templates with Robin, make GraphQL integration with Strawberry. And I came to also realize that not many people are available on Jitter, and the main reason to have a community communication platform was to make it more accessible. So we'll be migrating the community to Discord. And most importantly, try to increase the community involvement. Speaking of the community, join our community if you are interested in making PRs, doing reviews, sponsoring, or if you are just curious. Here is the link to the community. And special thanks to the people who are already there, the sponsors, the contributors. Without you folks, it wouldn't have been possible. So here are some of the important links. We have the GitHub link, the PyPI link, the website, the docs link. And yeah, star Robin on GitHub, and let me know if you have any questions.